¿Qué tal? Bien, ¿no? Magníficas ponencias. Bueno, yo soy analista de seguridad, no quiero perder ese rol.
All right, good morning everyone. I am a security analyst, and at this point in time I'm kind of changing that role. And why is that? Well, I work in 11 Paths, which is the cybersecurity unit at Telefonica, and the president of Telefonica has realized that there is a significant, important future for blockchain, and then he decided to set up a group that has been devoted to blockchain since the last year. I've been focusing on the topic primarily for the last 6 months. So before I start my presentation, I'd like to say that we have found very many challenges in our path, and I would like to share that with you, so that's just in case you are starting, so that you can learn from that. And as I was saying, this technology has gone through several phases. A few years ago, when blockchain started, we could see from the viewpoint of security that there were lots of malware and ransomware that were using bitcoins for the ransoms. And at that time, banks thought that there would be disintermediated. That is to say, that will be like no central bank kind of managing this new payment system through bitcoins. However, nowadays we are a completely different phase. We've been realizing that some people are already using Bitcoin, but however, we've seen that the technology behind that, which is blockchain. So everything, now blockchain is booming. Every day I see in the news that the shares of a company will increase their values because they are using blockchain, because they are doing this or that, or they are reducing the expenses because they are using blockchain. Well, sometimes I even think, will blockchain prepare me a coffee in the morning? Well, we should be very careful there, because this technology will not always contribute the huge potential that it has. So therefore, that is the purpose of my presentation. That is to say, to find out about the capabilities of blockchain and to develop solutions accordingly. And as I said, my background in security has been very helpful, because now I have to create a solution as a Telefonica. And the first thing that I think about is, who are my end users, those who do not have an understanding of the underlying technology, and therefore to whom I want to give them that security layer. So I will see how to set up architecture from scratch, using all the expertise that I have, with the aim to provide a level or layer of security to end users. Who is aware of blockchain? How any of you here has set up or created a blockchain solution? All right, so let's move on to it. So we will be talking about bitcoins as a currency, but all currencies are, there are very many currencies, and they are all different. When someone asks me, what's the difference between Bitcoin and any other currency? And I say, well, I don't know, give me some time, I will have to read about them, because they are all different. Okay, so this is the structure. First part. Alice wants to send out Bitcoins to Bob. To me, Alice and Bob are Angelina Jolie and Brad Pitt in the movies. So, Alice and Bob are the names used in technology books. Okay, Alice wants to send bitcoins to Bob. Both will have to have key or private keys associated to their wallets. So this is the structure. Starting point, a private key. So if you are tech savvy, you can really invest time in finding out how cryptography works in Bitcoin. So from a private key, a curve is applied. Then we get to a public key, and that public key applies a hash algorithm, and then in blue we have this bit, that is to say the address that the user will guess. Before that, we will have the protocol version of Bitcoin, and then we will have a number of subsequent bytes that we will be checking. That will be validating that address has been rightly or properly generated. So this is the first question. Are users ready to have private keys and addresses? So do I really want to give that power to the user, that is to say, to manage his private keys and addresses? How do you feel about that? Well, in traditional Bitcoin systems, users have power to manage the private keys and addresses. But what about users? Are users aware enough? Do they know that if they were to lose the private key, perhaps the money could be easily stolen? So the answer is no. Well, or at least this is how I feel. I'm sure that society will evolve, people will learn how to store the keys securely, but to date I think that we are not yet ready for that. But when I talk about this, I always use the same examples. I started working in this world because a colleague, Felix, well, in 2013 he was already mining. He used to set up his PC for mining at a time where mining was profitable, because nowadays there is specific hardware for mining, and actually we just don't even dare to compete against the PC in mining operations. Well, he was mining and he started to get his bitcoins, and then he realized that Bitcoin had grown, and he wondered, where do I have my keys? And then he found his wallets where the private keys were stored. However, that was protected through a master key, and a master key that was so long, so complicated to remember that he could not remember it. He had lost his private key and he could not move his money. Now he's got some 3,000 euros in Bitcoin and he cannot move that money at all. And my colleague is not technological dummy at all, but that happened to him. If that happened to him, imagine that could happen to ordinary user. Second question. Alice creates a transaction and signs that with his private key. Can we really estimate the volume of operations to create transactions? That is to say, if I create a solution based on Bitcoin or any other currency, do I really know how many clients will use my service? How many transactions and operations will each of my clients carry out? Can I really estimate the price or the fee that miners will charge me for each of the transactions? Well, as we should not forget that Bitcoin value changes every day. Bitcoin is highly volatile, so therefore it's very difficult to make this kind of calculations and estimations today. So therefore, other type of anchoring information in the Bitcoin chains are being looked into That is to say, pointing at other distributed addresses, and I will tell you more about it later on. So the answer is again no. We don't have that capacity. If we anchor that information in a chain of public keys, well, we cannot do that. That's why we had the arrival of private keys. That is to say, a time where a network has been created and no fees are charged for transactions. So people carried out transactions among agents who have authorization to carry out those transactions. And why we were talking about fees here? Well, at the end of the day, miners have two ways of making a profit. Well, either through coining new currencies, and depending on the timeline where you are, you will be making higher or lower profit. If you are fortunate to add the block next to the blockchain, that means coining a coin. So in the past, for adding a block, you would receive 50 coins. 4 years later, that was cut down by 50. This is halving process. That's the name given to it. So again, having and having. So the trend for miners is the following: the money that they will be getting will not be through coining, but through the fees of each user transaction. At the end of the day, the miner will get a profit from coining plus from the fees that will be added onto that block. And why are fees increased? Why is there this upward trend? Well, this is not a classic supply and demand graph. So this block is limited to 1 megabyte. No information bigger than 1 megabyte could enter in a block. So therefore, that space will become more and more expensive. The higher the demand, the supply will grow exponentially. And this is a clear example of that. 2017, there was a collapse where blocks were filled and fees were skyrocketed. I always give the following example. In 11 paths, twice a year, we are allowed to do a hackathon. The hackathon lasts for 24 hours. They let us program everything that we didn't program during the year for whatever reason, because it was not considered relevant or because the project manager does not allow us to do that. So as I say, in the hackathon, we program as much as we want. And I say, okay, happy idea, you can program it. And because we were interested in this system, we were looking into what we could contribute from security perspective. Well, we had already encountered the problems, for instance, of having users losing the private keys. And I said, well, we are a telecommunication company. Let's take advantage of our hardware elements, that is to say the SIM, where we may store information through a private key. And let us say, okay, let us try to do that signature operation for transactions within the actual SIM. So we achieved the challenge. We succeeded in our hackathon, but there came a time that we found that we had no bitcoins to do that. We had to buy it. We bought a few cents of bitcoins. When it came to presenting our solutions and say, okay, well, let us explain that we did the transaction, that we sent it, and then they say pending confirmation. It took 20 minutes to confirm our transaction. That's one of the problems that we have here. If we create a solution based on a specific blockchain, and we are anchoring that information in a chain of public keys. And I'm very much of a fan of public blockchains, which actually I think this would actually give sense to using this technology. You cannot really wait for 20 minutes. I cannot really picture myself going to the bakery to buy my loaf of bread and waiting for 20 minutes up until the transaction has been successfully completed. So, as I say, this is not feasible. And when this type of things happen, that's why we have these folks. Then we have miners as well as project developers saying, look, this is not working. Let us to fork, and then let us look into features that happened before. In coinmarketcap.com we can find a list of more than 1,400 different operations. People all over the world investing lots of time in looking into what is the contribution from each of these projects. And the first one of these folks is very relevant. It is important to be aware of when this happened for the first time. August 2017, the first fork of Bitcoin was created. What does that mean? Well, that means that the rules of the game changed. So that is to say, they lead to solutions based on prior solutions using a similar protocol to that of Bitcoin. However, new rules were established, rules that were not compatible with the original rules. That is to say, so this is the ordinary Bitcoin chain, but then I buy Bitcoin Cash here in green, but I cannot spend my Bitcoin Cash in the Bitcoin net. However, if I have Bitcoins here on top, I can spend them on both, in the Bitcoin chain and as well as in Bitcoin Cash. An example, WannaCry. Well, everyone is well aware of WannaCry. We were severely impacted by it. WannaCry took place in 17th of May 2017. I will never forget that date ever in my life. May 16th, extortion was carried out through 4 different addresses. Everyone who was committed was extorted through 4 different addresses. Each sample was allocated to an address, but when you did the analysis, at the end of the day, you ended up with 4 different addresses. Well, those 4 different addresses were the source of income for the person behind WannaCry, and I can't remember the actual figure, but this person collected a significant amount of Bitcoins. What happened? That was in August 2017. I remember I was in black hats, and Felix said, well, the whole security community, but I said, well, what has happened? Let us see when he moves this money, because by the time he will move the money, he will be caught. Well, Bitcoin has some degree of anonymity, but at the same time, it allows us to find out about all the transactions that are taking place in his network. We don't know who are the owners of those addresses, but at a given point in time, this person will have to exchange Bitcoins into money. By the time that exchange will go through a centralized service, the anonymity will not longer be there, because many exchange places for cryptocurrencies are kind of now asking people to identify all the users in their platforms. If you like these type of examples, we at 11 Paths carried out research halfway through this year about this, how to lose your anonymity in Bitcoin, because the person behind WannaCry was using Bitcoins. And here we could see that here we had money, but here down here the money was already being moved. So we had some indications that perhaps they were going through some mixes, that is to say platforms that in the exchange of you giving them money, the money is moved to other addresses. So that research paper is worth taking a look at. Is this the first time that this is happening? Not at all. That happened 15 days ago. Again, Bitcoin Cash developers and miners said this is not working. However, what was the difference between Bitcoin Cash and Bitcoin Gold? Well, we shifted from 1 megabyte difference between Bitcoin and Bitcoin Cash. Bitcoin allows only 1 megabyte, whereas Bitcoin Cash allows higher number of megabytes. However, in this case, miners and developers says Bitcoin is used as a method to anchor information. However, this is being too small. And now let us move on to Bitcoin Cash. And Bitcoin Cash now says, well, this is again too small. And all the projects that are being developed as a result of Bitcoin Cash are aimed at increasing the capacity of each of the blocks. So Bitcoin Cash maximum of 32 megabytes, whereas Bitcoin SV maximum of 128 megabytes to introduce transactions in each of the blocks. And we also have other type of protocol modifications, and here we had folks adding new features to our Bitcoin. In the case of Bitcoin, one example of a soft fork is that of the multi-signature portfolios. In the beginning, everyone had an address and a private key associated to it, but then they came out with a new feature that says, well, multi-signature portfolios where I share a wallet, and I share my wallet with 3 people. And then with those 3 people, I can associate or decide on the number of private keys to be associated to these people, how many private keys they should have signed for them to have authorization to move their money. For instance, if I create a company with 20,000 euros exchanged into Bitcoin, and I put them into a wallet, and I say that company belongs to Pepe, Manuel, and Yaiza. However, I need the authorization and the signature on Pepe and Manuel as a minimum for the money to be moved. Okay, so this is a multi-signature portfolio, and this is the way these new features are being used nowadays. So now, one more question. What about, well, the Bitcoin transaction is reported to the rest of the nodes in the network. If you go to blockchain.info, when we say reporting, at the end of the day, it is stated in the form of a pool pending to be signed transaction. Doesn't go right away to the blockchain and you see it reflected. The rest of the nodes receive information about a new transaction. So we create a pool and transaction, and then we will see what we do with that. And therefore that is followed by mining phase. If we go to blockchain.info, we could see in real time how many transactions are going into that pool of pending to be confirmed transactions. And we can also estimate the number of nodes in the Bitcoin network. However, when I create a solution based on a blockchain, well, I find this to be good fun, because nowadays I see very many transactions that are where we only have single nodes. What do I want blockchain for if I only have one node? One node are in charge of introducing transactions in the chain and to anchor them. So it doesn't really make sense to work with a single node only. So therefore, I really need to see how many agents, how many stakeholders will there be in my chain. Whether I would allow in a chain to have Telefónica, Vodafone and Orange, because we have decided to create a joint solution. And will they all have the same authorizations? Will they all have the same authorization for reading, for writing information? Well, we will have to decide who will be authorized to do what. Nowadays, these capabilities are not properly done. We don't even know how many actors we will have in the chain. Sometimes when you set up a solution, you are the only one allowed to anchor the information, and this is where all this kind of doesn't make sense. So blockchain.info, unconfirmed transactions, then you will get access to all the transactions which are pending confirmation. Next phase number 4. So one node will be in charge of adding it to the blockchain. I have introduced some transactions prioritized based on their fees, because miners will say that they would only include in the block the transactions will have the highest number of fees. They will create a block, and through the mining process, if they are in charge and they are lucky enough to carry out a mathematical operation, that is to say finding a hash starting with x0, that is to say a difficult hash, if they would be adding that block to the next blockchain. That's mining process. Do all chains require mining process? Well, in the case of a single node, you don't really need a mining process. You may go and say, yeah, well, blockchain is a contribution, it's good for me, even if I'm alone. Well, if you are alone, why do you want a mining process? You will be the only one carrying out those transactions. At the end of the day, you are wasting your energy. Sometimes you decide not to do any mining process and to use blockchain only as a way to anchor information, like kind of time stamping information. That is to say, if you want to say to any third party or to your clients that that information has taken place at this specific time point, and that it cannot be erased, that cannot be changed, well, that could be another possibility that you could have. And as we said before, here in the Bitcoin, in the beginning, you could ask your PC to do some mining for you and you could make some money. But now you are giving all your computing power to a mining pool, and if the mining pool is lucky enough to find that hash, to do that mathematical calculation and to add that block, you could return, you can get some payoff money invested. If someone asks you what blockchain is about, there is this platform anders.com, which is a website on where we can visually understand what blockchain is about. And information on each block that will be translated, that will be seen in the rest of the nodes. The rest of the nodes could report that that byte has been changed. Imagine this is Genesis block. This is the name that the first block receives. So block number 1. Well, in the Bitcoins, at the end of the day, we are adding on transactions. That is to say, I am adding on information. My system through which I check the money that I'm sending out or the money that someone is receiving, I say, okay, this is the address. This is Yaiza. Yaiza is sending out this money to Felix. Felix will be represented through a different address. Yaiza sends out 80 Bitcoins to Felix. I could here carry out as many transactions as I would like to. What is the information in this block? The block contains all this information. It is number of the block, then the name, then the data that I want to anchor in the chain, and then the previous hash. That's Genesis block, and therefore that previous information will be 000. And this is the mining process. Miners will have to carry out a mathematical operation whose hash starts in a different manner, and then we will have to calculate field nodes. then you click on one, and then you click on mine, and it says no, it has not been received. Number two, it doesn't, not successful, not successful, you don't come out to this resort. And then when you calculated that, you okay, 65,693, and they say yes, I found a hash with the level of complexity that you have told me.
Cada bloque siguiente.
Next block. This is added to the blockchain. Next one, same operation. Block 2, data. Felix is sending Pedro this number of bitcoins. Information in the block, information for the previous hash. We carry out the same operation of mining until we reach a number, which is this one here, with this hash. Okay, and then again, in the end, this information is replicated by every node in the network. The information has been duplicated, and the information, if we modify any byte of information there, and if we say Yaiza is sending 50 instead of 80 to Felix, it would be in red. It's a way, a visual way of saying modifying information that it's already anchored. This would be visible for the rest of nodes in the network. Phase 5. The information in this block is linked. That's what we've seen in Anders.com website. Okay, our system, which uses blockchain, is complies with the regulation and data protection. My colleague is here. She's here to see me. When we started to ask this question, I called her and I said, I have a huge problem because I'd never realized about this. I've been working with blockchain for many years and now I need to have a solution. The regulation is in force. And the main characteristics of this is that the information is unchangeable. I cannot erase it. What do I do now? And you see other solutions, and you say, I am creating a huge, wonderful architecture to comply with the regulation because I cannot erase my data. And we see these solutions implemented by other people, not in Telefonica and other companies. And the million-dollar question is, does it comply with the regulation? And they say, oh, we didn't think about it. Well, you should start to think, to prepare everything, to modify your architecture because it's going to be worthless. For a hackathon, it could be useful. Something that it's not going to be used by hundreds of thousands of users, but when the user needs the power to erase their data, well, you start to sweat. Why? Because of this, because information is unchangeable. You cannot erase information, you cannot change it. So any person with a copy of that database would have a list with all the operations. And if at some point you can track that an IP is linked to Pepe Perez, it's not just you, the one having the information on your users, but you're sharing it with Vodafone and who knows who else. They could say, okay, I read this whole IP, I have the list of this operation, this person has this amount of money or potatoes, I don't care, or this person has consumed this amount of energy. Before that, the solution we have is taking into account the information we anchor. We don't anchor it raw. This IP, which represents Pepe Perez, or this address, which represents Telefónica, Vodafone, carries out a transaction which represents Pepe Perez. In Bitcoin, there are native any person can see that a person has sent 3 bitcoins to another person. There are other blocks who do not allow me to anchor information. I can just carry out operations, and an ID of the transaction has been recorded. An address carries out a transaction to other address, but the information is not anchored. Then you have some sort of space where you can anchor information, but you don't anchor a hash. You anchor a hash and it represents information you've stored in other database, and there you can comply with the regulation because you can erase in your traditional database, because the only thing that you would have there is a hash of a transaction which would not represent anything. And this is very important. Bob says that he can use the bitcoins received from Alice, but does the client value that additional value offered by using this technology? The other day I read a paper that said that only 80% of the Spanish population hadn't even heard about blockchain. So, I think in this case, well, when we create a solution, we need to work with legal department, but also with the communication department. I'm using a technology which provides a lot of value, but if people don't know what it is, what am I doing? People don't value this. We need to highlight the capabilities provided by it. For example, the most important use cases. When we give this information, when the user is provided with the possibility of being transparent. If my use case is about transparency for the user and I'm anchoring the information in a private chain block, what am I doing? So my conclusion, yes, I skipped something. Another question. You anchor the information and the information cannot be changed. But who says that that information is not false? We haven't carried out a previous action which is validating the information anchored, that it's real, or maybe it's a mistake. I may have done an operation behind this and I see I need a transaction for this user for these Telefonica coins, but that transaction was wrong and I anchored 7. It's a mistake. So this translates as we can use blockchain when it makes sense. It gives us persistence, which is not something very useful because it can be achieved differently. Traceability, yes, everything is registered. Integrity information, okay. Because you can validate somehow that the information hasn't been manipulated and eliminated intermediaries, okay. With Ethereum blockchain, you can automatize processes. First, use cases. I thought it was going to be too long. I still have half my presentation to go. First, use case. Storing information. At the beginning, the information was stored in addresses when transactions were worthless. But now we cannot do that anymore. So in 2013, a new field appeared which is OP return, where we can anchor a maximum of 80 bytes of information. You don't anchor something that represents a document, that represents something else, but that you cannot carry out other operations. So we used other alternatives. Okay, allow this traceability because I'm using a public blockchain, such as Bitcoin, but I have to pivot to other decentralized networks, anchoring a pointer to another network, such as the case of IPFS. This technology is widely used and combined with blockchains, IPFS, or Merkle trees. There's a project by the MIT, free software, which is great for university certificates, or whatever. I imagine university certificates because we've had a problem about this in Spain, and I thought, well, this is the solution. The solution they suggest with Merkle trees, it's not that each person getting the degree needs to do a transaction for each certificate. In a traditional case, the university should say, my university address has been transmitted to another address representing the student. I've issued this certificate. Okay, you got this certificate at this point. But if you need, I don't know how many students are there at university. Thousands of students. If I need thousands of operations in bitcoins, well, should prepare the money. So at the end, what they do is anchoring the Merkle root in the blockchain. If I'm going to check this address, it's going to tell me that it matches and it is within that Merkle route. I think it's better explained here. Merkle trees help us to optimize the anchoring process of existent evidence. We use blockchain to test, to prove that something has happened, because they give us tools to confirm that a document has been used to create the hash at the origin. This has been used, all of them have been used to get the Merkle root. And once the Merkle root has been confirmed, we confirm that this certificate belongs to that Merkle root. Privacy by design, or security by design. Why? Because at the beginning, when we started to use this type of systems, people said, okay, addresses are linked to regular users. But addresses are personal data themselves. If we have a traceability that tells us that this address corresponds to Pepe Perez, and as I've said before, depending on how we anchor the information, if it cannot be erased, we wouldn't be complying with Article 17 of the regulation. Current trends with regards to privacy, there are 3 projects I'm in love with, which are Monero, Zcash, and Dash. Here has privacy by design. This doesn't have privacy by design, but at any given time I would know the addresses. We could unmask the origin, the destination of every transaction taking place in these networks. And then security by design. I come from the security world. I'm concerned about the user security. In the past, we've seen many samples of malware that steal the computation capabilities of machines that are mining. This is just an example, but there are millions of families of malware doing this. Another problem. It's not that I compromise the computation capabilities. I expose a website, for example, in which I include JavaScript code, and out of each person that connects to my website, they would be mining for me. This is legal if you include a warning, but that website do not usually include any warning that they're mining. They're using the computation capabilities of your equipment. There was an investigation carried out by Felix. You can read it on 11 Paths blog. And what a coincidence. Do you know what types of websites use this system? Most of them are video websites or porn. Yeah, they take advantage of that. The fact they're going to spend a while in the specific website. or when Real Madrid plays, football websites where you watch football matches. That type of threats can be detected in these sites because they know that you're going to be connected to the website for a while. How can we protect them? I love this project. It's by a Spanish team, Node Mining. They've created an extension, and each time you connect to a website, they inform you whether it's mining or not. The project we've seen, such as CryptoLoot. And we see there are other types of malware samples. I think they exist at the beginning of this year in deep web pages and in some forum. People sold and bought malware that monitors a clipboard. You cannot learn Bitcoin addresses by heart. You copy and paste, and when you copy, that information will go to the clipboard. And there's malware that monitors that's some strings that correspond to a Bitcoin address. When they identify, they exchange this with the address of the attacker. So when I'm going to carry out a transaction, but this has already happened in the banking system. What we're seeing with this system is that every threat coming from the banking system is appearing now. You copy and paste the address to which you want to send money, and it's replaced at that point by the attacker. You think that you've sent money to your friend, and you're sending to a third party. And that's something that's happening. So the final question to take home is, do we have a clear idea of the problem that technology helps us to solve? Sometimes a product manager comes and he says, have you seen a new use case? And I say, oh no, I need to analyze now if this makes sense, if they're actually taking advantage of the capabilities, or I'm just getting carried away by the situation in the market or the name of this technology. So that's what we should bear in mind. Characteristics of the technology, are we applying them correctly? Does anyone have any question, any doubt about blockchain? Well, this is not a question. I would like to say, but you've shown an extension against crypto mining. Yeah, not mining. What's the name? Not mining. It's a project by some Spanish guys. It's an extension you install in your navigator, and it informs you when you connect to a website. It informs you whether the website is mining, and you see because your CPU starts to work. And then, do you know any app for computers? Could you please show my presentations? Some navigators already include that type of alert. I think Opera. But video games, for example, include crypto mining. Well, we're speaking about websites. It depends on the web, but not. I'm speaking at PC level, not the navigation. I cannot hear your question. An old version of a torrent. But the torrent sites tend to have this type of threats. The paper in the post in 11 Paths blog, there's a list where there's a probability, or at least the first 100 dominium in Alexa, the most significant, most relevant ones in the internet, and we analyzed whether they had crypto mining, crypto loot, and we saw it was these ones, torrent or websites where you're going to watch a football team, but they know that you're going to spend a while in that site. It's an alternative mechanism to advertising, but you can do it if you inform the user.
¿No? Bueno, pues nada.